Io. Io is the most volcanically active place in the entire solar system. Hundreds of active volcanoes constantly erupting, fed by the immense gravitational stress of orbiting so close to Jupiter. Walking on Io's surface, you'd be dealing with molten lava fields, sulfur dioxide venting straight from the ground, and a surface temperature that swings from freezing to scorching. But the volcanoes might not even be the thing that gets you first. Here, the radiation levels are so extreme that a human without heavy shielding would receive a lethal dose in a matter of hours. Open space. The moment you're exposed to the vacuum of space, the pressure holding your body together disappears. Within about 10 seconds, the water in your blood and soft tissues starts to boil. Not from heat, but because there's nothing pushing back against it anymore. Your body swells. Your saliva and the moisture on your tongue and eyes start vaporizing almost immediately. You'd have about 15 seconds of consciousness before your brain, starved of oxygen, shuts down. Venus. If open space is a quiet death, Venus is the opposite. The surface temperature sits at almost 900 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is over 90 times what you feel on Earth, roughly the same crushing force as being half a mile deep in the ocean. And above it all, the clouds are made of sulfuric acid. Even NASA's toughest landers, built specifically to survive Venus, only lasted a couple of hours before the heat and pressure destroyed them. A human being wouldn't need clouds of acid to kill them. The heat and pressure alone would end things in seconds before the atmosphere even had a chance to finish the job. Atmospheric re-entry. This is what happens when you try to come home the wrong way. Spacecraft re-entering Earth's atmosphere are moving at roughly 17,000 miles per hour. Without a heat shield to absorb and deflect that energy, the friction against the atmosphere generates temperatures hot enough to turn the surrounding air into plasma. Thousands of degrees, enough to vaporize almost anything not specifically built to survive it. It's fast, it's violent, and it's a reminder that even getting home is one of the most dangerous parts of the entire trip. Sun. You don't need to touch the sun to die from it. Long before you got anywhere near the surface, radiation and heat would overwhelm any ship or suit ever built. The sun's corona alone reaches temperatures of over 1,000,000 degrees. Even the most heat-resistant spacecraft humanity has ever built, designed specifically to survive a close solar approach, has to keep its instruments shielded behind a heat shield just to survive relatively far from the surface. For a human, it would be radiation sickness and heat stress long before you got close enough to see the surface up close. Mercury. Mercury doesn't have an atmosphere to speak of. During the day, the surface can hit around 800 degrees Fahrenheit, hot enough to melt certain metals. But Mercury also barely holds on to any heat at all, so the second the sun goes down, temperatures crash to nearly 300 degrees below zero. Same planet, same spot, two completely different ways to die, depending on the time of day. Neutron Star. This is where things stop being survivable. A neutron star is what's left after a massive star collapses, all that mass packed into a sphere roughly the size of a city. The gravity is so extreme that the difference in pull between your head and your feet, even from a distance, would be enough to stretch you apart. Get close enough, and the tidal forces would pull you into a thin stream of matter before you ever reached the surface. If you somehow did reach the surface itself, the gravity is strong enough that dropping an object from just 1 meter up would smash it into the ground. Black hole. This is the one everyone's heard of, and it's exactly as bad as it sounds. As you approach a black hole's event horizon, the difference in gravitational pull between the part of your body closest to it and the part farthest away becomes so extreme that you'd be stretched, head to toe, into a long, thin strand of matter. Time and space themselves stop behaving normally as you cross the event horizon, and nothing that falls in, not even light, ever comes back out. If you want to see more videos like this, make sure to subscribe, and feel free to drop your suggestions for the next video in the comments.